Okay, in this section, we're going to learn law of sines, which is used on non-right triangles. So law of sines is used on non-right triangles to find the missing sides or angles. Because if it were a right triangle, you probably use Pythagorean theorem, or you would probably use SOHCAHTOA. So if we have no choice, then we have a choice of law of sines or the next section, law of cosines. So let's look at this non-right triangle. So let's say this angle is A, this is B, and this is C. And we know that the sides are ABC across from the angle. So this is little a, this is little b, this is little c. So we know, so basically law of sines is saying the sine of the angle over its opposite side is the same proportion for the entire triangle. So equal sign B over B, and that's also equal sign C over C. So we're only going to do the easy cases here in this section. So let's look at this first example. Solve triangle ABC given that angle A is 36, angle B is 48, and side A is 8. So let's go ahead and just draw a triangle and write ABC. Angle A is 36, angle B is 48, and side A is 8. So solve the triangle just means find everything else. Okay, so let's just label everything. Angle A, angle B, angle C, side A, side B, side C. Okay, so because there is no right angle anywhere in this triangle, we can't use SOHCAHTOA. So what we want to do is look for things we can actually do. So we know this angle and its opposite side. This creates a pair. So this allows us to use law of sines. So you need an angle and its opposite pair. Okay, so we know this pair. Um, this angle is also known, but the opposite side is unknown. So we can use this A angle and pair to find side B. So how do we do that? We know the angle 36 and its opposite side, so that creates one proportion. And then angle B is 48. We don't know what side B is, so we set up the proportion. So to solve this proportion, what you want to do is use cross multiply. So cross multiply, that means you cross and multiply. So sine 36 degrees times B is equal to sine 48 degrees times 8. All right, we're solving for B, so we're going to divide by sine 36. So B is equal to, it's really awkward writing the number last, so I'm going to write it before sine. This divide by sine 36. So now use the calculator and find B. Okay, so side B is equal to 10.1. All right, so let's fill in everything we know. So this is 36, B is 48, side A is 8, and then we just found B to be 10.1. All right, now we need C. We don't know anything about C. Or can we find out something about C? Well, we know that C, according to triangle sum theorem, the interior angles of a triangle must add up to 180 degrees. So you can solve for angle C from there, which is 96 degrees. Okay, so then my triangle is drawn kind of strange. 96 is bigger than 90 degrees, so it should be a obtuse angle. Anyways, let's go ahead and solve for side C then. All right, so we're gonna still use the proportion. You can use any proportion you want now because we also know side B now. But I'm gonna just keep it to this angle A proportion. So we know that angle A is 36, so sine 36 over side A is equal to sine 96 over C. All right, so you're going to solve for C the same way. So go ahead and pause the video, come back and check your answer. Okay, the answer is 13.5. All right, so let's go ahead and have you pause the video and give this following question a try. All right, so maybe you got to sine 49 over 32 equals sine B over 28, and you weren't sure what to do from there after you set up the cross multiply. Well, this is the same thing as before, except you're going to do one more step. So you're trying to solve for angle B. So the first thing is you have to divide by 32. And now you need to get rid of the sign. Well, you can't get rid of the sign by dividing by sign. That doesn't make any sense. What you need to do is you need to get rid of it by using inverse sign. So you're going to put this number into the so after you calculate that number, put it in the calculator under inverse sign. That's going to give you an angle. So B is equal to 41.3 degrees. All right, if you haven't solved the triangle yet, go ahead and give this a try. Come back and check your answer. All right, go ahead and check your answer. All right, now we have a word problem. Two observers are 400 feet apart on opposite sides of a flagpole. So like this, they're on opposite sides. So one person's here, the other is here. They are 400 feet apart. The angles of elevation from the observer to the top of the poles are 19 and 21. So let's say this guy is 19, this guy is 21. Find the height of the flagpole. Okay, so what you cannot assume here is that this is 200 and 200. You cannot make that assumption because there's nothing that says the flagpole is in the middle of them. So what you have to do is just work with whatever is given to you. So we're given basically a triangle with 19, 21. This is unknown. This is 400. You have to figure out the height in between. So what should you do? Well, you probably want to figure out this angle first from this triangle sum theorem. And then once you have that, you can see that this triangle has this pair to utilize law of sines. And then that tells you you can probably solve this side, you can solve this side, and then you're going to figure out how to find h. Okay, so go ahead and pause the video and give this a try. Come back and check your answer. Okay, so h is about 72.6. All right, now in this section, we're going to talk about law of cosine. Law of cosine is very easy because it's just the Pythagorean theorem generalized. Okay, so let's say this is a triangle ABC. This is A, B, and C. So let's say, if we had the Pythagorean theorem, we would say A squared plus B squared equals C squared. Except this time, I'm going to kind of write it backwards. So I'm going to write C squared is equal to A squared plus B squared. So to use this theorem for non-right triangles, what we need to do is subtract 2AB cosine C. And what that means is this AB is this AB here, and then the C is kind of that angle for this side. So let's say I change the formula so that we're trying to find the side A. So then we're going to say, okay, then the formula is going to be the other two sides squared, so b squared plus c squared minus 2bc, because those are the two sides here, and then cosine a. Okay, so then again, if I change up the formula so that we're trying to find b, then I would say, okay, that formula is a squared plus c squared minus 2ac cosine b. Okay, now let's see how we can utilize or use the formula. So let's look at this triangle, A, B, C. So let's say side A is 11, side B is 5, angle C is 20. So let's first see if we can use law of sines. Law of sines requires an angle side pair. So this angle, we don't have its opposite side. This side, no angle. This side, no angle. So we cannot use law of sines. We have to use law of cosine. Now, how do we apply law of cosine? What we would do is we would look for two sides and the angle in between, which is here. Then we can find its opposite side. So since this side is opposite of angle C, we're going to call this side C. So side C squared is equal to side A squared plus side B squared minus 2 times side A, side B, cosine C. So C squared is equal to side A is 11, side B is 5, minus 2 times 11 times 5 cosine C. C is 20. All right, now let's take a look. When you solve this, please make sure you do it carefully. This is one term, one big term. Do not do something like this. Put this part in the calculator and then multiply by this. So this is very incorrect. That is going out of order of the order of operation. So please be careful. It happens a lot. Please maybe just write it out. So for example, I will probably write 121 plus 25 and then minus, and then I put that whole thing in the calculator just to double check what that number is before I plug everything together. All right, so let's go ahead and do that. Okay, now let's put that in the calculator. So 121 plus 25 minus 103.366. 42.634. All right, a lot of people get to this point and they say done. You forgot one last step, which is square root. So square root that, you get 6.529. So this is the answer. All right, so let's go ahead and have you solve the rest of the triangle. So we angle A we don't know, angle B we don't know. Angle C we know is 20. Side A is 11, side B is 5, and side C we don't know. All right, so what we want to do is, this is a little bit tricky. When we solve this kind of triangle and we get to a point where we did solve one where we have a pair that we can use law of sines, it's better that you don't. Because what happens is law of sines is not able to detect whether the angle is an obtuse angle. What that means is if an angle is an obtuse angle, it will always tell you the angle is acute. So then you can never figure out if that angle is acute angle or an obtuse angle. So what you want to do is, if you had to start with law of cosine, I would suggest that you just finish with law of cosine so that you can get the correct triangle. So that means if you want to find angle A or angle B, you got to use law of cosine. Okay, so I'm going to set it up for you. You're going to solve for angle A yourself. So angle A, since angle A is the angle you're trying to find, you're going to start with its opposite side. So formula that uses its opposite side. So A squared is equal to B squared plus C squared minus 2BC cosine A. Okay, so I'm going to write this on the side. A squared is equal to B squared plus C squared minus 2BC. Oops. 2BC cosine A. Okay, let's plug everything in. 11 squared equals 5 squared plus C is 6.529 squared minus 2BC and then cosine A. Okay, so when you solve this, you're solving for A. Please use the correct order of operation, meaning you need to take 11 squared minus this, and then you're not going to add this part, okay? You're going to divide because this whole thing is multiplied to cosine A. And then you're going to use inverse cosine to find A. So go ahead and give that a try. All right, that means angle A is equal to, oh, let me just come back here. Angle A is equal to 145.783 degrees. Angle B is going to be really easy to find. It's just the triangle sum theorem. So this is 14.23 degrees. Let's look at a different example. So let's say that we have this triangle ABC. This time, you don't have any angles. You just have 3 sides. Side A is 9, side B is 7, and side C is 5. So let's say you're trying to find angle A. Then you're going to start from its opposite side. So you're going to start, if you want angle A, you got to start from side A. So A squared is equal to B squared plus C squared minus 2BC cosine A. Okay, now you want to plug everything in and then go backwards and find side angle A. So go ahead and give that a try. All right, angle A is equal to 95.739 degrees. Okay, using the same method, go ahead and figure out B and C. Okay, go ahead and check your answers. The last part we're going to do is finding triangle area. So we usually write area formula as 1/2 base times height for a triangle where base and height have to be perpendicular to each other. So for example, if we have a right triangle like this, then the base is here and the height is here, and they have to make a 90 degrees. So then if we don't have a right triangle like this, then it's a little bit harder. So for example, if we have this obtuse angle, then the height would have to be this one here. So this would still be the base, but then this height, this is the height which we don't know at this point. And in this case of the acute angle, so then what we have to do is we have to again draw a perpendicular line, and then we would have to call this the height, and then this is the base. And so that gets a little bit tricky because we don't know what the height is. So there's a kind of a formula to get away with all that, which is the area, whoops, is equal to 1/2 AB sine C. Okay, sine C, what does that mean? So usually we have a just 1/2 BH or base times height. Now we have three other, I guess, variables or letters to use. So how do we go about using that? Well, this is not as I guess hard as it looks like. What you would have to do is you're given, let's say you're given any kind of triangle. It really doesn't matter. So triangle ABC. Then what you would do is the area is going to be side A So 1/2 times side A, side B, and then sine of the angle in between, which is always going to be C. So that means 1/2 of A times B, and then sine C. Okay, so let's look at one problem that we can try to solve this together. So find the area of a regular octagon inscribed inside a circle of radius 9 inches. So this looks a little bit tricky, but it's actually not that hard. It's kind of interesting trying to figure this out. So you have a octagon, so that means 8 sides, and a regular meaning all the sides are the same size. So it's not just a octagon with 8 different side lengths. They're all the same length. So that means you can actually just think of it as 8 I guess congruent triangles. So they're exactly the same size. So how do you find this area? Well, you know the area, the radius is 9, so that's 9 and 9 and 9 and so on. And to find the area of one triangle, you just need 2 sides and the angle in between. So we do have 2 sides. We don't have this angle in between, or can we figure out what the angle in between is if we know that this whole thing forms a circle of 360 degrees, right? Okay, so give this one a try. It's not as hard as it might look. Go ahead and figure out the area and come back and check your answer. Okay, so the answer is 229.103.